start streaming, let
Yeah.
me know.
Yeah, you can start streaming whenever you're ready. Perfect. Okay, we are on. All right. You want me to post the link on the AOPS thread? Is that weird? I mean, I want more viewers.
I'll
That's
be back.
why.
Give me a second.
Okay, then I won't post it yet. I'll wait until you're like back.
Yeah.
All right. So, how is everyone today?
It's
Good.
Monday. So
It is
yes.
Monday. First day of classes for me.
Oh, how are your classes now?
Calc 3 at UNC.
For a moment.
Is that your only class?
For today, yes. My school starts tomorrow.
Oh. What? Okay, sure.
My UNC classes started today.
Or class. Okay.
All right, well, we're live. I have not put out the link anywhere yet. So
I'm
if some
back.
people are like, okay, you want me to put out the link?
If you really
gonna-
want to.
No, I'm putting out the link on CNCM absolutely. I haven't done that yet. And then AOPS, I'm considering it.
You're considering it. I mean,
I am actively considering it.
I don't think Oxford cares.
I think maybe I've advertised too much.
wait, can we get Eli on here? Like, why is he just like not here? Fortunate.
Lectures.
Yeah.
At
He does want
POTD.
to. Okay.
At Twitch ping. At YouTube subscriber.
Don't ping POTD. Do not
I'm
ping
pinging
POTD.
POTD and you
Don't
cannot
ping
stop me.
POTD. Why are you pinging POTD? They didn't sign up for this.
You know what? I don't care and they can leave.
No.
Okay.
No, we don't want them. What?
That's amazing.
Zoom is live. Everyone in this server is expendable to me and I'm kidding.
Don't ping POTD.
I'm kidding.
Ping
I'm-
POTD.
I'm pinging POTD, yes.
I'm
Okay.
not pinging POTD.
Okay. Someone,
Black gay
whoever-
kids from Florida.
whoever runs the command ISL RR1 on general first,
No.
I'll take that problem.
No.
We're already streaming. 2007 A1. This seems like.
Where's the stream link? How do we view this stream?
All right, and then I'll go onto the AOPS thread. You know what? Can someone else bump them on the AOPS thread? Is that okay?
Can I move this?
Where's that noise coming from? We're live.
There we go.
Whose house is that? Let's see.
Wait,
is it
can you
Eli?
see the problem
That's
on the
Eli.
stream?
That's Eli.
It's Eli. Eli, get rid of your background
wait.
noise.
I can advertise Oliver if you want me to. Yeah.
Okay, yeah. Who wants to make Eli?
Do you want to be referred by your full name, Nacho, or no?
Oh, Doctor. Wait, Doctor is currently in general.
I mean, last time he joined the stream and started playing like music on rhythm, so let's not.
That's true.
Hey guys, sorry I just joined. What are we doing? Wait, let me get some paper.
Live ISL solves. I want to bump the CNCM YouTube channel AOPS threads so bad.
Okay, I'm going to hope that Doctor does not start spamming, hopefully.
Okay,
I said it would do Geo today if the bot gave me Geo.
And it did.
It didn't give me Geo. It gave
Yes,
me...
it did.
No, look, the first
Didn't it?
person to run it was
Oh, yep.
Radiant. And it gave me 2007 A1.
Unfortunate.
Wait,
Unfortunate.
hold up. Can I join the
Yeah.
I do some?
You can't write on
Are
the
you doing
whiteboard.
this one
Can
right
you
now?
share the whiteboard with people? Is that possible? Ziteboard? Someone search that up. Why is the quality so bad?
Can someone whoever has the whiteboard, can they stream it on Discord?
I'm streaming on YouTube.
We're streaming on YouTube.
But there's lag.
No, Oxford.
Yeah,
You can do collaboration with Ziteboard.
Really? How?
I don't know.
Eli.
Yes.
Do you want to tell people that we're live
Holy
solving
shit, there's a giant
ISL?
moth in my room.
Oh,
Real-time collaboration tool. So how do I
okay.
share it with people?
Yikes. Is that an ant? Okay. Seriously, please.
Here we go.
Perfect.
How do
Why do you keep don't let the doctor in here? Why?
I'm not sure.
Just don't let him in here. Never let him in here.
2004 GO1, that's being specifically requested. I don't know, maybe. Up to Oxford. Let's
Oh,
Eli,
Yes.
do you want to bump the CNCM YouTube thread or should I?
You can do it.
guys, make accounts on Zypeboard.
Thanks.
You can use Google to sign in, and then I'll
Where's
share it with you.
Whiteboard?
Wait, what's the website?
Zypeboard. That's what I'm using because
Zypeboard?
I can invite people by email.
Whiteboard.
It's
Log in
much
with Slack.
it's much better than Sketchpad.io or whatever we were using last time. Sketch.io.
At
Okay,
what
I made
point?
one.
At what point does it become like completely and totally unacceptable for me to keep using AOPS as an advertisement platform?
I think you already
I don't
crossed the
know.
line.
Yeah, that's true.
Maybe. It's okay. I'm gonna send it.
We should
Okay, I'm
probably
on
start
Zypeboard right
doing
now.
this problem.
How do I continue in Zypeboard?
Can you invite us?
Do you guys have accounts?
Yes.
Oh, yeah, I'm in my people. Can I like? How do I like? Can I put like a random thing?
What are we talking here?
I'm going to actually. I don't want to expose people's emails, if you know what I'm saying. So I'm going to put a little blockade for now. I'll change back
I
later.
don't
That's
really care.
nice. That looks kind of cool.
I don't know. This is just me messing around on OBS. Okay. Can you see anything on the stream? Like I just put like a blue box.
There is nothing on the stream right now. It is a blue box.
Is there a CNCM logo though?
There is a CNCM logo, yes.
Yeah, okay. Let me share it with you guys.
Honestly, is someone else okay with bumping the thread? Because like I feel like I've crossed the limit.
Wait, Eli,
I
DM
think
me
you
Okay,
right
already
I'll
now.
do
have
it.
it.
I'll do it.
Thank you so much. Okay,
What do you
I'll
want me
send
to say?
something. We're currently live streaming ISL solutions. I don't know. I'll send you the link. Here you go.
Okay, you guys should have invitations in your
No, I
emails.
feel like I feel like your reputation in emails couldn't go lower.
I
Probably okay if you.
Yeah, but I don't
Oh
really
wait,
want.
why am I doing this? I can just give you guys the link. Wait, I might
I
have
don't
already
know.
exposed the link to the public, but I don't think they care. Hopefully not.
Okay.
I'll DM it
I
to the
bumped it.
admin
No.
server. Wait, does Radiant want it? Radiant, do you want the thing? And Sucrus, do you want it?
I don't really trust Radiant to do this.
You
I
don't
feel like he's
trust
gonna
Radiant.
troll.
He has
I
good
don't know, I feel
intentions.
like he's gonna troll us.
Wait, what? No,
Alright.
no. Wait, want.
You guys are
You
like
trolled the
zooming out
screen
the thing.
before. Why would you not troll us on the whiteboard?
Why would I troll
Okay, I
you
think
on
I'm
a
back.
live
I'm back
cell?
on the main. Yeah. Okay, there's like a bunch of like.
Wait, Oxford, give me the Zypeboard. Give me the Zypeboard link.
Okay, well, the way you're saying it makes me really suspicious.
Alright, well we sent out the thing on AOPS just now. So
Okay. I don't know what this like random like thing is. Like there's like a thing here. I don't know what this is. Like do you see this?
Oxford, share the Zypeboard with me.
No, I don't trust you with the Zypeboard.
I mean yeah, that's kinda valid.
Can whoever's zooming the Zypeboard stop doing that?
What?
Sorry. Wait, let me go to an empty canvas, okay? Let me go to an empty canvas.
What are you doing?
I think this
I
is
have
good.
no idea.
Is everyone on the same page? I don't know why there's like this like dotted box. Do you see this dotted box? Like,
What?
I don't know why that's there. Full
Can we
screen.
stop moving it?
Oh, I can turn this to full screen? I never knew that. What? Why did I only hear
Bro, I'm
about this now?
completely trustworthy. Just share the Zypeboard, bro. That's it for a moment.
You can give ideas, but I'm afraid I can't share you the Zyport. See, who did that?
All right, well, let's try to get this started. It's okay.
I don't know why there's like a dotted line, but I think it's fine. I don't really care.
Okay, I haven't even seen the problem. Holy crap. Let me look at it right now.
Alright, no one Zoom, okay? All of you who are on the Zyport right now. No, I also sent you the link too if you wanted to.
Me?
Yeah, just
Where'd
don't
you send it to? Oh,
your email.
got it.
Actually, no, in the admin server. I mean, sorry. Where's
Your
the
email.
2007 A1?
Need to log in.
Is it the part one by New Zealand?
I think that was it. I'm using Oliver bot made by Nacho on the CNCM Discord. If you want to use it, it gives you random ISL prompt. It's great. Join the CNCM Discord and you can use it all you want.
Can we do a geo problem?
I don't know, the random thing gave us an algebra
Let's do this
problem.
for now. Let's do this for
Like,
now.
can we not do another algebra? Like, at least do some like combo. Like we did NT, we did algebra. We
I
move
mean,
on to
let's just
something
do one
else.
more. I mean, this seems like a really interesting algebra problem.
Really, you think so?
I mean, okay, let's do Geo. Okay, I'll guarantee Geo next round, okay? Happy with that?
I don't,
No,
this thing is annoying. I don't
you
want to do
did.
this one.
Okay, fine.
Yeah,
Fine. Fine.
Not doing this one? Bro, I was literally doing it, bro.
Okay,
Okay.
half of us want to do it, half of us don't want. Who's
I
doing
don't care. I don't care. Just do whatever.
it? Okay, fine. Someone get. Someone do ISL RG1. Kick that out.
What's our next problem?
Okay.
Is it this problem? The by Georgie Arabidze?
Yes.
Yep.
But
Okay.
now
I'm
the
not
Can we
thing.
just
picking you, Radiant.
can we have a diagram, please?
Yeah, that's the problem. I have to go to GeoGebra now. Let me change my setup.
Okay. Oops, I did not mean to do that. Let's keep that in the corner.
I think that should work.
Oh, yeah.
How do I expand this?
Prove it, Radiant.
Let me not put this in the. Let me not put this in the corner. How do I move this?
I put it in the corner. Why?
Because it's
So we have
full
more
Don't put it,
space.
screen.
don't put it in the middle.
Okay. So I have GeoGebra open.
you
See,
do have to move it over a little bit. Like, yeah, right there. That's perfect.
I do have GeoGebra open, so I can draw. I can draw this figure, and then I think I can snip tool the figure and give it to you guys. Hopefully. See if that
Uh,
works.
GeoGebra is not cheating, right, chat?
Okay. How do you expect us to draw a figure?
That's fair. I mean, like, it would be very hard for you guys to see what our work is if we aren't using GeoGebra. Um,
Okay. This is gonna be something, isn't it?
and it
Does anyone want to provide us with a diagram? Like, do I have to draw?
Yes.
Wait, I
Fine.
just realized
and someone
I did this
kicked
problem in
Radiant out
Echo
again.
yesterday.
Let's move Radiant to stream.
Yeah, let P and Q be on segment B, C have an acute. Okay, I had the problem with me on the right. Okay, what is this? Oh no, I didn't lock my preview.
PAB is equal to
Yeah, I can't read the
BCA.
problem simultaneously. I think. Never, I can. I can. Hold up. I think that should be good. Okay, so you're just
Isn't
gonna.
this an Egmo?
Expertly
Yeah,
drawn triangle.
this is 2014-4
Wait,
IMO.
wait, that's wrong, isn't it? Like that's not how triangle numbering
I'm
works.
not gonna lie, I don't remember the solution, but I feel like I've seen this before.
Let P and Q be on segment B, C have an acute triangle.
No,
ABC such
I
that
won't say what
no,
PAB
chapter it's from though.
no.
equals
What?
BCA.
This has been how
Okay.
I draw all of my triangles.
Wait, do you
Like
not do it?
forever.
Do you not do it counterclockwise?
I do it clockwise.
You do it
Clockwise.
clockwise?
Bro, it's
Why do you do it clockwise? That's like
Clockwise is
counterclockwise.
like what a normal person does. You
I'm
don't.
pretty sure it's
No,
supposed to be
no, no.
counterclockwise.
What?
No,
Chat,
triangles
Oh,
are
the
chat,
supposed
superior way is to do it like this. Wait,
It's
oops.
chat.
also it's
Clockwise or
PAB is equal to
counterclockwise?
BCA. It's not PAC. You know what? Let me just draw this on GeoGebra. Like,
Yeah, just draw it, please. GeoGebra, please. I have a sketch on my piece of paper, but like, the sketches only get so far.
Let me pull up
see,
my
like,
sketch. on
even
the tool.
GeoGebra does counterclockwise.
Yeah.
Or
Wait,
it
wait,
might
But
just
don't
be
you
that
have to
I did
actually
that.
wait, Oxford,
wait, don't you make
use
it
the
on
polygon tool
GeoGebra?
instead of
I
the
don't think GeoGebra has
segments.
a set definition.
Okay, wait. ABC, PQ on segment. Okay. Okay, that means I have to like make PQ like really specific. This is annoying.
Angle conditions are hard to do in GeoGebra, I think.
That's true.
You midpoints.
Let M and N be the points on AP and AQ.
MNN.
Wait, what? No, Oxford, just copy the angle and then like find the intersection.
I'm not good at GeoGebra, so if someone wants to like give a diagram and say it in general, then
Few days ago.
Oh,
use a
peak
variable for the
laziness.
angle.
Oh.
For a moment.
see, I'm
Yeah,
not the
this
one
is,
who wanted to do a geo problem. Like I'm not good at geo, but unfortunately, I should probably get better.
Yeah. I don't know how much help I'm gonna be. I can be helpful on number theory to an extent. I could be helpful on algebra. Geo
Bruh, no
is
one does clockwise. I'm just reading the chat.
everyone. Okay, everyone who. Did you know that if you don't do clockwise, then it's mathematically proven that your IQ is less than
Oh,
3.
someone actually drew this out.
You.
that is not a circle. Mm.
Drew
That's
at
nice.
the
That's such a
intersection
nice.
of B, M, and C.
This is such
Yeah,
a.
this seems like a EGMO problem. It seems
I've
familiar to me as well.
I think you've done this problem before, but it's kind of late in the book.
I don't know, it just seems familiar. I guess it's not for me. I might be spamming.
Similar to a chapter 2 problem, but it's not exactly that.
Fine, I'll draw this on GeoGebra. What is this?
Where's the GeoGebra, please?
I'll just do the geographer one.
Okay,
A and QB on
shout
segment
out
BC.
shout out to AOPS user 216. That takes commitment watching the live stream while solving POTP.
True.
PAB equals
Dedicated CNCM members.
PAB
We love them.
equals BCA. So BCA is just a specific angle. Okay, let's see here. Angle
Yes.
BCA. Can I copy that?
Just copy the angle.
How do you copy an angle? Can you do that?
Yeah,
No,
you
you
measure
just
the angle and then you
measure
can
the
set it to a
angle and then
variable
paste in the
under the
symbol.
equation stuff.
I don't know how to do that.
Bruh.
What?
It's not that hard. Just use the angle tool.
You know, I'll just like it'll be roughly equal. I'll just set it to 36.9.
You know, go click the calculator button.
Okay. Oh, like alpha?
Yes.
I see.
Yes.
Okay. So if I go,
Just type a command to like set angle or whatever.
I have never used commands on GeoGebra.
Me neither.
Or no, do angle given size.
Yeah. Wait, so what's it? PAB? So
No, you can just put in alpha.
let's see if I can. How do I type in alpha though? Like,
Just copy it from the.
Copy paste the letter alpha. You have to actually copy paste the letter.
Yeah.
I think someone else should insert the GeoGebra diagram.
I know exactly.
Google alpha symbol on
This is
Google.
very sad.
The issue is Oxford is streaming. Even if we do, actually, I'll just make it and I'll send the GeoGebra diagram, like the GeoGebra file.
Counterclockwise?
I know,
No.
but you have access to
What?
the
No,
what's it
no.
called? The page.
No, Oxford, do it counterclockwise from AB. Wait, never mind.
Oh, phew.
I was close. Okay, so does that mean I can move this around? No, I can't. This is a really bad idea. I don't know why you guys made me. Oh wait, never mind. I got it. I don't know what I did.
Just delete the verdict. Bro.
Wait, yeah, okay. So let me just get that angle. That's alpha. Have that in my clipboard. Angle with given size. BA counterclockwise. And this. What? Why did my file show up? That seems like almost right. Is that just how I drew the triangle? Yeah, it's pretty cool. Oh wow, okay, so I did it. Can I delete this point now?
No.
I can't.
Okay, so the reason.
Wait, what? How do I delete this point?
Oh look, it's Kazoo.
No. Actually, you just have to hide it. Just use the hide button.
No, what? Isn't hide just H though? Is it not?
Moved to stream.
You can't use
Hello.
delete stuff because things are defined after certain points.
Okay.
Who's this guy?
Oh yeah, it took me a while, but I did it. Let me just,
Who's Zero Man?
Wait, why are you doing Geo?
cause
I should
Shop
do.
wanted me to do Geo, and Harry wanted me to do Geo.
It's Buckshire.
See, this is the problem with Geo, okay? It just takes way longer because we have to show you setting up the diagram.
No, it's just because Oxford doesn't use GeoGebra.
Can we do
Wait, hold up.
like
Who,
combo
like,
or number theory instead?
Who
Like, don't want to look
unironically
at a
likes
diagram.
Geo? Like, it's gross.
Wait, is my blue screen up? Wait, what's up right now?
I'm checking. Yeah, it's blue.
I have the diagram.
You do? Yeah, 1 second.
Um,
I'm trying to do something. I did something by accident. I messed up.
Right here, I'm gonna post the GeoGebra diagram in the admin channel.
Oh my gosh, I cannot do this problem. I literally read the problem wrong. I'm so stupid.
And then let me just get an image.
Whatever. Alright, I'm back with the Zeit board.
Try an image with the Zeit board.
You just copy and paste.
I copy an image.
Where do you want to copy an image?
What? I want to pose an image.
So
Insert
do you have it in your
image. There we
clipboard?
go.
Do you have it in your clipboard?
No, I don't have it in my clipboard.
Snip tool it first.
I got it from Snipping Tool.
CNCM Livesolves ISL problems, Geometry Edition.
Wait, what happened? I was
Where'd it
erasing.
go?
I erased it by
What?
accident. I'm just
Okay.
trying to erase this. So. Yeah.
Okay. Here we go.
Wait, are
I'm
you not
pasting
using
it.
the GeoGebra diagram?
Here is the GeoGebra diagram.
Oh, thank you.
That took a
Finally.
while.
I
The long
think
wait
it's
is
stuck
over.
I think it's stuck now.
We can't do anything about that.
I'm sorry.
What's
All
that?
it says prove that the intersection of BM and CM is on circle triangle triangle ABC.
Yeah, to prove the X is on the circumcircle.
All right.
Oh, why did you do
Delete
it?
it.
Who deleted it?
Undo.
What? Do you still have it in your clipboard? Just like
There you
okay. Why
go.
do you
I
paste it
never
there
had it in my
again?
clipboard. I'm uploading it from my computer.
Stop. Holy
Stop.
crap.
Wait, no.
Who's
Okay, wait.
doing
Who's doing it? Okay, wait. The whole problem's gone
No.
now. Alright, listen. Okay, Harry, paste in the diagram and move it to like the right.
God.
What is happening? Okay.
What is
I
this?
think this is easier when just
Okay,
Oxford has access.
no, move it to the right. Move it to the right. Move it all the way to the right. Not all the way to the right, but a bit to the right.
Who's
Yeah,
drawing
stop
on
there.
it?
Stop there. Okay, perfect.
Who is drawing?
Not
I
me.
put gamma on it because I'm trying to angle chase.
Okay. And now the problem is there. Okay, that's perfect.
It's not perfect. I can't see it.
There you go. Thank you, whoever did that.
There we go. That's good.
That took a while. Wait, so yeah, so PAB equals BCA. Alright.
I want to make sure that.
Can I make my pen like
Okay.
this is amazing drawing.
Okay. So stream. Chat. Can you see the problem clearly on your end?
It's too small for me to write anything.
YN in the chat.
Oh,
Okay, then let's
crap.
just like make the image very large.
Okay.
Like I
No.
think our goal is
No.
clear.
They said that they can see it clearly. It's fine. All right. We're good.
If we make the diagram like really large, then we can actually start working on it.
Yeah, exactly.
All I'm seeing right now is a pentagram.
This guy.
I'm not wrong though.
I mean, yeah.
Okay, okay, here's what we'll do. So, Harry, do you still have the diagram on your clipboard?
No, I have to upload it each time. I never had it in my clipboard.
Oh my god, what have I
What
done?
was that sound?
I don't know. I think that's from my computer. My bad.
Okay.
Oh my god.
Is this better? No, we don't need the problem. We don't need the problem.
You were not using this last time, weren't you?
I wasn't using this last time because it had no collaboration. It was also okay. No, let's just zoom in completely into the diagram, okay? And then we'll worry about
This
the
is
problem
very
later.
cursed.
Because we have all the information we need. You can read the problem on the right. Like, what are we doing? I could keep it like this. This who's zooming out and stuff?
Hey, what the? I didn't
Where's
erase
the
that.
drawing?
Let's do this. Let me just erase all this. Annotations. Okay, we're good. I have the problem in my clipboard. I'll post it when I have to.
Yes, PQMN is cyclic. I did notice that. But I literally don't even have my compass right now, and I'm free. I have it free-handed on my paper. This is pretty difficult. Whoever uses mu for an angle is bad. I agree with that statement.
Yes. I've seen that before, and it was in a physics problem too.
I'm actually gonna draw this
So
diagram
I
on
was,
my paper.
Isn't mu used for like for coefficient of
yeah,
friction?
coefficient of
Wait,
friction.
can you
Yeah.
paste the diagram again, Harry?
Yeah, it was a
Kidding
physics
me?
problem. So I was
It's gone.
solving it as if mu was coefficient of friction, like a normal human being, and then it was like, nope, mu is the angle.
Okay, there we go. Wait,
And
can
we're
we
like,
like?
what?
Oh wait, no. I wanted to scale it up. Wait,
Move it.
I can. No, when you paste it in, expand it like really big, or something like that.
I
Theta
need
is valid.
Deal with it. Oscar, just deal with it.
Okay,
Just
fine,
deal with
fine, fine. Okay,
it.
this is a good setup. Okay. Wait, who's zooming in? Okay,
I'm
that's fine. I
zooming
don't
because we
care.
can write bigger.
Okay, so
This is
PA.
enough.
Okay, okay, so I have my pen on the thinnest setting. So we have PAB is equal to BCA.
Don't you just love how we've spent 30 minutes and we have not started solving the problem?
That's because people wanted to switch to Geo.
This is all your fault, guy.
Hey,
I'm
so
kidding. You're all cool.
PAB
So we see that PQ and PQ and M is a isosceles trapezoid, right?
What?
Right.
QMN is isosceles?
Yeah, yeah. If you just angle trace around.
That makes sense, yes.
By basic angle chasing. I don't know if I should be looking at my paper or the screen, but because the screen is kind of hard to do stuff on.
Oh.
Is there a way for us to find? How do we want to prove that ABCX is cyclic though? Like, do we want to find this angle right here? Is that what we want to do?
Find what angle? Where?
Wait, I'm scared, Harry. I think if I try to erase that segment, that the diagram will disappear.
Don't
Yes, it will.
don't erase it.
Oh.
Never erase, just always undo.
Okay.
So okay.
So we want to. So I think our best shot might be to find something like that, which will require. Wait. Actually, yeah. See, I'm trying to organize my thoughts when I don't actually know what I'm doing. It might. It would be very bad to do a complex bash on a stream, right?
Let's not bad. Let's try not to bash these.
Don't bash on screen. Don't bash.
Someone suggested berry bash, which actually might be nicer than complexing.
Berry Bash makes me excited, but I don't know how much it'll work.
Bash
I
on-
always want to do Berry Bash when given the chance, not because I particularly like the method of solving the problem, but it got us 1.5 thousand views. So,
Nice.
Yes.
I don't know, to be honest, right now. I'm a little puzzled.
How do you use the midpoint condition?
Yeah, the midpoint condition is important.
I
Well,
think.
yeah.
Oh, never mind. Do you want to hold up? Are you allowed to annotate on GeoGebra?
Yes.
Why don't we just annotate on GeoGebra?
Because that involves me switching to GeoGebra and I'm not very experienced with it.
So like, why don't we just all get on a GeoGebra?
Is that possible to
Can we all get
collaborate?
on with it?
I don't know if that how GeoGebra works though.
This is why I didn't. Actually, I don't know. I'll let you guys do Geo. I'm not good at Geo.
I'm not good with it either. But hold up. Oh, I'm too distracted. I can't actually solve this problem right now.
Seems much easier to solve on paper than on stream.
Why don't you just try length bashing then, like power of a point?
I don't know.
This is kind of awkward.
Yeah.
We spent 30 minutes trying to set this up, and we were making like trivial discoveries. Hold up.
See, someone said this is why we don't do Geo.
This is why we don't do Geo. Well, maybe.
Sound.
what is this problem?
I don't know. I forgot. What was it like?
It's
Geo.
2014 IMO4, I think.
2014 IMO4.
Yeah.
Wait, we're not supposed to solve problem 4?
No, problem 4 is equivalent to problem 1.
Yeah.
I know, but
It's a G1.
oh, it's an actual IMO problem.
I'm
Yes.
pretty sure it is.
I think, I don't know.
Yeah,
I'm just
yeah,
going
it
off for
is.
Shab.
It was on the IMO.
Ammo.
Can we find this angle? These angles, please.
Which angles?
The
The
angles that I just marked.
Okay.
And also find like, oh, there's just so much writing. I don't want to.
I mean, those are parallel lines. I don't know. I'm not good at you.
Okay, wait. So what we're trying to prove, okay, is that the intersection of BM and CN rather, is on the circumcircle of ABC.
Yeah, so we just want to prove that this point lies on this circle.
What you can do by proving
So
that
those two. So if that's true, then those two angles have to add to 180 degrees, right?
Which two angles?
Well, that's already a given because it's an isosceles trapezoid. BDC and BAC.
BDC. Where's D?
No, sorry. Like, I don't know. I have it written down on my
Oh
paper
no.
as
Oh,
Q.
okay, good.
I have it written down on my paper as Q.
Yeah.
It's the intersection point.
Yeah. BQ. You're saying something about something. Oh wow, so I actually removed all the annotation.
Wait, no. I have two Q's on my paper. I need to redraw my diagram.
Okay.
The point where what's it called? NC, right?
Mm-hmm.
NC and BM intersect, okay?
Yeah.
Let's call that point something. What should we
X.
call that?
X.
X?
Yeah.
Okay. Then since it's an so then angle BXC and BAC add up to 180, right?
Well, yeah, that if they're cyclic, then
How
Yeah.
do I express this?
listen, you're supposed to prove that the quadrilateral is cyclic, so ABXC. And then if you prove that it's cyclic, then you finish the problem because then X lies on the circle. But that's the problem. You have to prove that it's cyclic. So you have to prove that somehow with like angles by the
Well, we can
diagonals.
see that. Okay, well, we can see here that triangle QCA is similar to triangle. Wait, hold up. What am I saying? QCA is similar to PAB, which is similar to triangle PAB ACB, I think. Correct me if I'm wrong. So it's so hard to look at, darn.
I'm actually going to transfer this to my paper so I can actually make some progress.
Okay,
Alright.
so triangle ABC is similar to triangle
I'm gonna go for like 10 minutes. I'll be right back, okay?
QAC similar to triangle PAB, right? Make that look like a B. Who
Sorry.
zoomed? Okay, yeah.
Can I drag the problem into view? Unfortunately, it would mess everything up.
So
Okay.
What?
Actually, I'm gonna draw this on my whiteboard, like my actual whiteboard. Where
we
is?
do get a bunch of ratios here. So we can get so we do know that AP is equal to PM and AQ is which is also equal to AQ, which is also equal to QN. So somehow we can get some nice lengths out of that. QA, we see that QA over AB is equal to see, this is equal to AC over BC equal to CQ over CA. Are any of these particularly nice? I don't think so.
Found something interesting.
Hmm?
The tangent at B and the tangent at B is perpendicular to AM.
The tangent at B is perpendicular. You mean
You
parallel?
mean parallel?
Parallel to AM.
Yeah.
Interesting. Okay.
The proof for that is that the tangent of B and the
Yeah,
tangent of
that makes
B
sense.
intersect at something that you can draw like a harmonic bundle or something.
Wait, hold up. That actually makes sense. That actually makes sense. Yeah.
That's kind of like is the entire problem.
That trivializes it.
If you draw this, please excuse my horrible lines. Let me zoom out a little bit, see where these lines connect. Oops.
Sure. I'm just managing the stream at this point, so.
Does this kill it? It looks like, so it looks from first glance that A, X, and whatever this point is, look collinear. So if we can prove that, why is there? Oh, what am I doing? 1 plus 2 equals 3.
It would make a lot of sense because AX and the intersection this looks a lot like a harmonic bundle configuration.
Yes.
And then we can project from B like the line through AX, and then we can project that to get APM and the point at infinity.
I see.
If it's parallel, of course, we got to prove the converse.
Wait, what do you mean prove the converse?
We have to go from. I think we have to prove that the tangent at B is parallel to APM to AM, right?
Didn't you do that just by interfacing?
Wait, this finishes. Hold up. Okay, because like if you think about it, you get that we already know that P is the midpoint of AM, right?
Yeah, projected finishes.
Yeah.
And then if you take B, if you project from the line APM about B to the circle, A gets fixed, P gets sent to C, and we see that what is it? The line of at infinity gets sent to B. So that means that the intersection of M and BM has to intersect on the circle
What?
at a point X, such that A, B, X, C is a harmonic bundle, right?
Yeah.
Oh.
And then if you do the same thing for the other side, so if you can do the same thing with about if you can make the same argument at point C, then we see that that CN has to intersect at that same point because there's only that one point that can make the harmonic bundle.
Right. Okay. Yeah. No, that, okay. Okay.
Yeah, so that should finish the problem.
Okay. So wait. So what we have to prove is that Wait. Do we just have to prove that the tangent at B is parallel to AM, and then we're done?
Yeah, essentially.
Okay. Well. Okay.
Okay, let me undo all of my lines because it's really messy.
This shouldn't be too bad to prove, right? Because it looks
It's
like could be
almost-
just.
This looks like a standard angle chase to me.
Yeah, it's pretty immediate.
Okay. Well, let's do it.
I'm just clearing my stuff so we can have a cleaner board. So we want to prove that the tangent at B is parallel to AM, and then we'll get the other. If we can prove that, then the other result should also follow by symmetry. So the tangent here, we want to look at. Can we like GeoGebra, please? I want to use GeoGebra, but this is just an image, right?
Ask Akshar. Where is Akshar?
Yes.
Can we just have like one person streaming on GeoGebra, and then and everyone else just like helps out by voice?
Yeah.
I'm not
Yeah.
sure. I mean,
Let's do that in the
if you want to
future. Let's
do
just do, let's
GeoGebra
just
on
finish
this, you should probably have someone other than me, because I'm just watching you do this at this point.
Okay, so well, let's just finish this problem for now then. So we want to prove that this tangent at B is parallel to AM, and hopefully that will finish the problem. So
Yeah.
yeah,
How do we do that?
That's easy because this angle right here should also be this angle right here, and then we see that this angle is this angle the same, so it's parallel. Yep. So we should be done.
Oh dang. do you want to make a little? Okay. Wait. So okay. We do an actual. If we do like a full proof.
You want to do a write up right now?
Yeah, just like a kind of like a write up or something.
You can
Those intersect
use-
at one point.
You can use sticky notes on the top right. Like there should be like a square with like a folded.
Okay,
line
I'll
across.
write it.
It's much easier to show.
Oh. Wait, so
What subject are we gonna do next?
Not
probably
Geo.
combo.
Please no Geo.
Probably combo. That's the only one we haven't done yet.
I am back.
Yeah, so we did
Hello, Noah.
number theory in the first stream, algebra in the first stream as well, but we actually never, like, ourselves, we didn't solve the algebra problem. The Geo problem got solved.
Okay. You know what? No, we didn't solve the algebra problem
I know.
ourselves. Nope. Nope, we didn't.
I know, that's what I said.
Nope. Nope. Definitely not. Nope. I didn't do it. I didn't tell you the exact step, and then you ignored me, and then when someone else said it, you were like, "Oh, that's a good point." Nope, didn't happen.
Okay.
Can I see the sticky notes?
I'm kidding. I'm just salty.
Yeah,
Yeah,
you
I can
should
see
be
it sticking
sticking out.
Oh,
Oh,
shoot.
whoa. See if we can move that. Yeah, I don't know. I don't know how these sticky notes work. I just know that they exist.
Arnav is best girl. Heart emoji. Alright. Cool.
Right, and so we've proved that they're tangent, and so we can project. So if we project A comma N semicolon, if we project the harmonic bundle A M P P infinity onto the line AX, well, we get that
Is it like illegal to assume that it's cyclic and then work backwards from there?
Yeah, that's illegal.
that's illegal.
Oh.
Yeah, so you can't assume anything.
No, but I'm saying it's given that that's ultimately going to be the result, right?
No, unless all of your steps are if and else if statements, or I'm sorry, if and only if statements, that doesn't work.
Reversible
Well,
statements. Is that what you mean? I don't know.
I guess reversible statements, yeah. Unless all of your statements are reversible,
Talking
that
about
doesn't
two
work.
different things, but that's okay.
In Geo, very rarely are they all reversible.
Oh, hey, 55 views already. That's kind of nice.
Okay. Well, anyway, yeah. Wait. So we can prove that B, the tangent at B is parallel to AM, and so that means we can project AMP, the harmonic bundle AMP P infinity, onto the line AX, from the point P B, and so we have that AX whatever the I'll label this Y and then Z. So AXYZ is a harmonic bundle. Likewise, we can, I guess, do the same with AN, and we can also, and then we get that, and then we get that AX. Oh, wait, yeah. So that just proves it's a harmonic bundle again. Wait, R and S be the intersections of BM and CN with the circumsurface circle of ABC respectively. We want to prove that R is equal to S.
We ultimately want to, like, prove it by similar triangles, right?
What?
Not exactly.
Okay,
I
yeah,
mean,
that should be the proof. I just typed
Wouldn't
it up.
that be one way to solve it?
I'm sorry, what did you say?
If we can prove that there are similar triangles, right?
It seems like a hard task
No,
to do that.
we already finished.
Like the angle conditions are hard to manipulate to get.
You
similar
finished?
angles.
Yeah,
Yeah, we finished using projective.
Ah, I see.
just typed up
Well.
a proof. Wait, do you guys not see it?
No, I see it.
Okay, good.
No, we do see it. There's sticky notes on. Let me see if it's on the preview. Yeah, it's on the preview, so people can see it. We're watching the stream. Should I give Rashab access to this whiteboard? I know he's not gonna spam.
Nah.
Yeah.
Well, no, Rashawn's gotten more spammy lately.
Oh,
Why has everybody gotten more spammy lately? Is it just me, or have certain people in the server gotten more spammy over time?
so have
I know
you.
Radiant
We
has.
can't help but feel that this is a personal attack.
Well, no one's been the same.
Rude.
His presence in the server has been largely the same. I think mainly Radiant and Rashab. I don't really know why.
Would you say that my presence on the server is mostly spammy?
No. Can we go on to the next problem? We're done.
Is there a next
I
problem?
want to finish reading that.
Oh, yeah, I'm finished. Okay. Yeah, take your time.
Projecting from B gives ARCB as a harmonic bundle?
Yeah.
Is this the same CB? Wait. How did you project this? Oh, sure. I'll just move on.
Okay.
New problem?
Doctor,
What do
can
you
you
mean?
capture that?
Capture this?
Yes.
What do you mean?
Like, screenshot it, save it somewhere.
I can't really.
Okay, I'll do it then.
It's fine. It's saved on the
I'll do it.
live stream.
It is also on live stream, but it's best for. Okay,
Okay,
so
there we go. Okay. So let's move on.
Alright,
so
what problem?
Harry wants us to do a combo.
Yes.
Combo
Okay,
We
is
will do
fine.
all 4 subjects to make everyone
Only
happy.
Oliver tell us to do.
ISL RC1. Boom.
I can be useful in combo. I didn't
Okay.
realize that you guys had solved
2012
it already.
C1. This is
Combo is
actually
impossible to do on a whiteboard though, but whatever.
really
Impossible?
interesting.
It's
Why is it
even
impossible to do on a whiteboard?
because everything happens in brain.
Okay.
Well, just like, you don't have to write out every single one of your
Do you guys see the
steps, right?
problem? Let me just check if it's in the preview. Yeah, it is. Okay. So yeah, so there's the problem, I guess. So several positive integers are written in a row. Iteratively, Alice chooses iteratively.
Okay.
Alice chooses two adjacent numbers x and y, so it's x is greater than y, and x is to the left of y, and replaces the pair x, y by either y plus 1x or x minus 1x. Prove that she can perform only finitely many.
Is this an invariant problem?
Maybe.
No idea.
So someone wrote a sequence here.
Invariants and monovariants?
X left to the y. So x has to be greater than y.
CNCM lecture? Noah Scheinbaum?
If it was just x minus 1 comma x, this would be trivial by pigeonhole or not pigeonhole. I don't really know what it would be trivial by, but it would be trivial. So it's the y plus 1 thing that's an issue. Monovariant.
So iteratively, which means I'm guessing she does this from start to finish, I guess, and then keeps on doing it again and again. I'm not sure, like, or does she just pick two numbers randomly? Oh, never mind.
Oh, why do we zoom? Oh, okay.
Let me check.
I'm just writing down random. I'm just looking at random things to see what
Yeah.
we get.
Alright, so can I get Chrome on here? No, I can't. Okay.
How did you get to 3, 5, 7, 4, 11?
I used the y plus 1 comma x.
Yeah.
How?
Okay, so I think the general idea here is just to prove that, like,
The sequence
how do I
becomes
express this?
That 1 equals 2?
like the sequence becomes eventually decreasing, but not like strictly.
Increasing.
Yeah. Increasing? Oh yeah,
yeah.
no. Yeah, increasing. Sorry,
Non-decreasing.
I switched it up. Increasing, but like not strictly
Non-decreasing.
increasing. Yeah, non-decreasing.
So,
That x minus 1, y plus 1 bit off to the right is not showing up on stream. I just wanted to make sure you guys know that.
Those are just my
The
own
what?
notes.
Oh, okay.
I don't think it's really actually.
so
We can like
So-
let me like scroll the board just a little bit like that. I think.
Okay, I think I found something. Wait, so if we let n denote the number of consecutive pairs that are I guess are decreasing. Each operation either preserves n or decreases n.
wait, what is n again? Sorry.
So like n is the number of like consecutive pairs that are decreasing.
Well, you can say that, like, for example, like, okay, going with that argument, like, there are some cases that where it keeps it the same, right?
What?
Or it keeps it the
There,
same.
like, there are some operations that operations you can do that preserves n, right?
Yeah, some operations preserve n, but none of them
Yeah,
increase them.
but like, you have to prove that that can't just keep infinitely happening.
Yeah, so you got to prove that. Yeah. So
Oh, Math Aces in chat seems to already have the
so
solution.
anyway, the first operation always decreases n.
Whoa, who's scrolling?
That makes sense. I'm sorry, I didn't mean to. I didn't know. Wait, scrolling on my side scrolls on your side too?
Yeah. That's weird, but I
Platform
mean,
is
it's
gross.
doable as long as no one scrolls or
Okay, well,
zooms.
the first operation always decreases n, and the second
Yeah.
operation always keeps it the same or decreases it.
Yeah, so it's mainly this option because this obviously
And so
makes it decrease.
essentially, the
increase.
second one can only finitely decrease it for obvious reasons. So then we're done. Is that it?
It doesn't sound right.
So wait, so
But
x, y.
it doesn't sound right.
I feel like
Wait, does this second function on first function always decrease n?
Sorry.
it always decreases n, right?
Wait, am I not on the
Why?
pen tool? Yeah, it does.
I thought n was a number of consecutive pairs.
Well,
N is the number of consecutive pairs that are decreasing.
Yeah, consecutive pairs that are
Oh, yeah,
decreasing.
yeah, actually, he's right then, because you can pick. They don't have to be consecutive.
Well, no. Well, for the sake of the problem, it's defined as the number of consecutive pairs that are decreasing because it only
Oh.
matters if they're consecutive. If they're not
Well, yeah,
consecutive, who
but this
cares?
first function doesn't necessarily decrease n then.
It does though, because
No, look, I literally, I gave an example of it not decreasing.
how does that? I don't understand what this step means. I don't understand what that step does. Like, how did you do this step? No, it's two adjacent numbers. You can't pick two.
Oh, it's
numbers
adjacent.
that are-
Oh, really? It is?
Okay. Oh, I'm actually
Oh,
blind.
actually, I
Okay.
thought the same as
Okay,
you,
then this
Eli.
problem
I
is
thought they were.
easy.
I thought they didn't have to be adjacent.
Oh, I'm actually stupid. Yeah. Okay, then. Yeah, that kills the problem.
We're done.
All right.
The problem was trivial.
Wait. What?
I mean, it just makes sense logically. Like, if you perform a certain amount of like, the second operation, you'll eventually like.
Yeah. If we look, you can only perform the second operation a finite amount of
Yeah.
times.
Before you get it to be increasing or equal, something of that sort. So is that
So Harry, you want
Wait,
to
so
test
that's
it?
it?
what?
That can't be that can't be it.
You probably have to prove why the second one can only be used finitely amount of times. But if we can just do that, it should be pretty trivial to prove.
Why
If we can do that,
does
it's
the
done.
tool keep on like? Let me check the preview. Is there anything missing? Oh no, the stuff on the right's not important. Okay.
Oh wait, no, sorry. There is a situation in which the second step increases n.
Really?
That's unfortunate. Yeah, if you have uh 5. Darn it, what's happening? If we have
Someone's
what the heck?
Sorry.
If we have 5, 5, 6, 3, or no, I'll just do 5, 5, 3. If we decrease the second 5 here, then it becomes 5, 4, 3, right? And then suddenly the n increases to 2.
Well, then you can just edit n to be the number of equal or less than. So just non-increasing.
Well, then we just have 5, 6, 3, and then it goes to 5, 5, 3, and then it increases.
You're right. Yikes. Yeah.
This is trickier than I thought, but darn.
Wait, what? How did you? What operation did you do on that? What?
I'd operated on 5, 3, and 6, 3.
But which operation?
The second one.
Y plus 1x?
X plus y.
Oh, I see.
X?
Okay, I see. Never mind. That makes
Frick.
Wait.
I'm also misread it. Sorry, guys. So this would become 4, 5, and then 5,
Yeah.
6. Okay. Well, no. Okay then. Okay. No. Okay then. Okay. In this case, then it always keeps n the same or decreases it. Okay.
Oh, okay.
Okay.
I keep on getting confused. Yeah,
And then
so
we run some argument like
6,
Okay,
9.
something to notice though that we have, let me write this in a color. Hold up. So something to notice is that here that we have both x's here. I feel like that's kind of interesting to note.
That's true.
yeah.
I mean, yeah, we always have x eventually. The thing is with y plus 1.
So it looks like, okay, because the idea here is
Wait.
that you're always shoving the bigger one to the right. So like since x is
Oh
first,
yeah. Wait. What if instead of defining n as the number of consecutive pairs, we define n as the rightmost consecutive pair that is decreasing? Then n is always decreasing, no matter what.
wait, so x is like how far the rightmost pair is?
Yes.
Uh,
The rightmost, how far the rightmost decreasing pair is.
why does that always decrease?
Well, I'm sorry. If we apply the step on the rightmost one, then it decreases. If we apply it on ones before, then
You're not inclined to apply it on that rightmost pair.
Yeah, but then okay, then we have a sub. Okay, so if we look at just the subset then of the left, so
Oh,
if
okay.
you
So we can ignore that part
non-rightmost
and
one, then we have a subset in the middle one. It's
okay.
yeah.
Okay, I
So
see.
that would that would decrease, and so that, of course, you would eventually have to stop applying it on that one because it would reach 0 on
Okay.
that little subset, and then which means you have to apply it on the next farthest most at minimum, and then
Yep.
that of course would destroy it, and basically you just iter sort of proof
Yeah,
like that.
that makes sense. You can just consider the leftmost.
The leftmost?
Wait, hold up. Actually, no, I'm not saying. Yeah, I don't know what I'm saying. Wait, hold up. So let's see if I understood you correctly. So let me write an example. Hold up.
Okay.
So
You're right.
if you have, for example, like 5, 3, 7, 1, 11, 9, 4. Okay. Right now,
yeah.
the rightmost pair is 6, 4, right?
Yeah.
So we're gonna look at, so if we assume, so if we apply an iteration on here, the rightmost pair, this is no longer the rightmost pair, right?
Yeah, so n would decrease into n.
Yeah. So
N
now you
equals
want to assume that it's never applied on here. So we're just staring at
yeah.
this remaining part and where the
Or
rightmost.
it would be this remaining part.
Oh shoot! Yeah, you're right. Yeah. So the rightmost pair would become So this becomes, and then it becomes this, right?
Yeah, and that would be the rightmost pair.
Yeah, and then we just have to, and then we can, and then if, wait, why did that box come back? So if we
Okay.
never applied on this pair, then we must have never applied it on. Look at, then we just ignore that pair and the rest. Look at the rest, right?
Mm-hmm.
Wait, hold up. I'm not sure if that exactly works though, because like if, for example, so because I'm thinking about like, so we know that if we apply an operation on this pair, that it will no longer be decreasing, right?
Hmm.
Sorry, what?
So we know that if we apply an operation on this pair, it's no longer decreasing, right?
Yes.
So we want to prove that if we that no matter what, we're eventually going to have to apply it on here, right? Like we
Yeah.
can't apply infinite amount of things here. But thing is that we can still change the value of 6 due to like applying an operation on 9 and 6. Hold up, I have no idea what I'm saying right now.
Well, if it has it on 9 and 6, you can change the value of 6, but unless if it changes the value of 6, either it still remains greater than 4 or it remains not greater than 4, in which it would decrease n. So even if you apply an n 9, 6, it would either decrease it or keep it the same,
Okay.
which is what we want. As long as it
Okay,
doesn't
so then
increase.
we're only okay, so then we just keep observing the
Each like thing. Then we probably just induction this
uh
or something. Obviously, this one here it's going to end. One application of either of these two will end it here, and so then we move on back onto this one, or it might affect. One might appear here, but I think can it appear there?
this is not as clean as I thought.
Not as clean. Yeah, one could, even if we apply in here, something could appear here.
Yeah.
But even if it here, it still has to end, of course. And then we consider this, it has to end. Then we consider this, it has to end. Consider this has to end. Then consider this has to end. And then yeah, then consider this, and then it has to end. And then yeah, something along those lines.
I feel like the induction's not gonna work here. I feel like there's just a cleaner formal invariant here. It's
Mm-hmm.
like proof Ah.
For the sake of making this as edgy as possible, we're gonna make this a 4.
Wait,
Or
why did
yeah,
we make it that 4?
because if you apply something on here, then this becomes a 5, and then you have
Oh,
something
okay,
out here.
okay,
Then
okay. Um,
Albert is pleading us not to overthink this.
yeah,
Albert is a pro. Honestly though, it's kind of hard to think when you're doing it on a screen. I'm just not used to this, but and especially when you have to communicate what you're thinking to the other person, it's a lot harder. You don't get to
Not
focus
even
on what you're thinking about.
not even super clean either. If we have 5, 3, 2, 4, I think this is. Okay. I think this is just gonna get annoying to prove. Darn.
The math aces is asking us if we want a small hint.
I think this is finishing. I think this finishes. Hold up. So okay. So wait, I'm actually not sure. Well, what we were talking about earlier, doesn't that finish the problem? Like consider our whole sequence. So we want to prove that that this whole sequence, that there's going to be a point where we cannot apply any iterations, right? That's what we want to prove, right?
Mm-hmm.
So and we know that we want to prove that the rightmost pair eventually just left, right?
Yeah, the rightmost pair is
Just has to continue to go to the left. So and we know that applying an operation on that pair will move the rightmost pair to the left. So we can think about just this box for now, right?
Yeah.
And then it's just the same problem. We're just on the same problem again. So and then we just reduce it to smaller and smaller boxes, right?
Pretty much.
Until we're left with a trivial box.
Yeah.
Isn't that it?
I feel like it should be. What if we have this? What if we have the edge case of the sequence being 5, 3, 4, 3?
Math aces in the chat says, yes, you guys kinda got it.
Yeah, yes, this is basically it.
Hmm. So look at the sequence I just put on the screen. 3, 5, 3, 4.
By the way, 14,
This
in
should be
case you
it. I
guys...
actually don't know why we're talking about this more. I think this is it.
Yeah, take a look at this one. 3, 5, 3, 4. If we apply it on here, it doesn't decrease n. It actually increases it. If we so applying either of these, okay. So if we apply either of these, we get something like 3, 2, 5, 4, and then suddenly this is the rightmost one.
I don't hold up. I don't think the string can. Oh wait, 3, 2, 5, 4.
3 becomes 3, 2, 5, 4. Operation on 5, 3.
Wait.
Wait, hold up. Yeah. Wait, I just had a random thought. I think this is simpler than I thought. Hold up. You can just say that the number of pairs just is. Hold up. Okay, hold up. So let me get myself some space so I can kind of explain what I'm thinking. So if you have like 4 numbers, like say W, X, Y, Z, right? And let's say X, Y is the only pair, right? Only non-increasing pair. That looks like an X. Hold up, sorry. Okay, Harry, do you see that?
Yeah.
So we see that if we apply a move on this pair, we're either gonna get that this pair disappears and no other pair appears, or this pair disappears and this pair appears, right?
Yeah.
We can't get that this pair appears, right? Can we?
You can.
Oh, we can.
Yeah.
Take a look at the example I gave as well.
Oh
Three,
my
two.
god. Okay, just make my head hurt.
Wait,
Is
guys,
it
I
is
got
it
an
possible?
idea. I'm not
What
sure
is
if it
your idea?
works though, because like whenever you perform an operation, you always move the greatest number to the right.
You always move the greatest number to the
Well,
right.
well, yeah, because obviously x just moves to the right, and then obviously on the left you have a smaller number.
So you move the
Right.
greatest. Hold up. So you're okay. Wait. I think I know what you're talking about. So
And then like
you want to
doesn't it get forced that eventually like your greatest number just goes all the way to the right or something like that? I can't complete it. I'm not sure if it works. Because like if you take a number, obviously, if you ever because you'll be forced to perform an operation there again, because if you
So
had like
I just boxed the numbers that are greater than everything to its left.
yeah,
So I think this is a good step. So mm,
it's kind of like a sorting algorithm, but not really.
oh shoot, true. Okay, this works because you can't
Yeah.
have any new red boxes appear.
Yes, that was what I was trying to see if that would appear, but
They
thinking
can't
here.
appear because
Let me try an example. Hold up.
yeah, they can appear. No new boxes can appear.
This. Nope,
Sorry.
that's wrong.
Oh, okay.
83, 316.
So if no new boxes appear, can we wait? I'm not. This is not a foolproof though, but
Yeah, it's just an
the
idea.
general, yeah. It just in my head, it kind of makes sense. There's no new boxes that appear.
Oops. It should be either 82 or 4.
Oh, I'm tired. So we see that each move take of that consists of a. We see that each move that consists of a box and a regular number, non-box number, sends the box to the right.
Hey, but didn't you say like, the box was like the number that was greatest to all the numbers to the left?
Yes.
But that doesn't mean like the right could be greater or something. I mean, oh, never mind. The right would be a box then. Sorry.
So yeah. So and then if we have a double box, then we would have that this becomes
But a double box is already increasing. So you just,
oh
I
wait,
mean,
yeah, double box is increasing. So
so you
you can
can't perform an
only
operation on that.
yeah, you can do operation on them. So we see that each and then if we have two standard numbers, then they just become
Well, can Can a standard number exist? Yes, it can. Let me think about that. I need to write.
Yeah, so non-box number. Oh no, I think a box can appear. Hold up.
Wait, what situation would it appear in?
Wait, I
Wait,
think.
I'm thinking right now. So, yeah, never mind. It can't appear, yeah. So we see that each move that consists of two non-box numbers goes to two non-box numbers. And we see that a move that consists of a box and then a non-box becomes a non-box and boxed.
Just writing down my
Right?
thoughts.
Cap.
No, what do you say?
Someone wrote in chat 2 words invariant cap.
What is an invariant cap? Oh, an invariant cap.
So our problem has, since we know that if we just want to prove that we cannot do finitely many of these kind of moves.
What do you mean? Finitely? You mean infinitely many?
I mean, infinitely,
Yeah.
yeah, sorry, infinite. We just want to prove that we can't just infinitely keep doing these moves.
The thing is, the way you prove that is that you just keep on sorting. Like, wait, let me think about this.
Can you ever decrease the amount of red
Actually,
boxes?
I accidentally timed out somebody. How do I untime them out?
No idea.
No idea either.
Wait, can
Sorry.
red boxes ever decrease?
Well, the boxes do appear. I have
Yeah,
no
yeah,
idea
wait.
how.
Yeah, that's what I was trying to say. Because if you sort this as
Isn't
1,
the goal
3,
just to
4,
create a whole bunch of red boxes?
yeah, this is all
Yeah,
just
we'll
boxes.
just create all boxes.
Kumar Gupta Reddy.
Hold up, then where do boxes appear?
I think you defined boxes incorrectly. There should be another definition for the box. I think you're on the right track, kind of.
Isn't the box? Wait, so
I
the
think you should
boxes
try to
is
like.
the box is defined as any number such that all numbers to the left of them are either less than or equal to the number, right?
Yeah.
Wait,
Hold up.
wait, what if you make another like, what if, okay, I don't know if I'm right or wrong. I might be spamming. If you made a box, like, the definition of
The
if any number to the
maximum
right is less than.
the maximum number in the sequence is invariant.
Yes. We see
Okay.
that.
The
So
math
I'm just
aces
gonna do.
says that
I'm
that's.
just gonna do a bunch of operations on 5, 3, 4, 1, 11 and see what we get.
By the way, I'm not sure if you guys like care about this, but we have 16 watch hours on this right now.
Nice.
Wait, so I
Cool.
have an idea. I'm not sure if it works. So what if you defined a box as like the numbers? If there's any number to the right that's less than the actual number, then you box it. And then you show that the boxes
Oh, that's where the boxes
keep
come
on
from. Okay.
just keep show that the boxes keep on decreasing eventually. Show that they can't ever stay the same infinitely many times, something like that. Do you get what I'm saying?
Sorry, I wasn't listening. What?
I was like, if you defined a box, like I'm not sure if this works, but if you defined a box such that like you box a number if there exists a number to the right such that
Wait, hold on. Can you say that again?
if there exists a number to the right such that the number is less than the like okay, let me say you had 11 here, right?
Okay. Wait. I don't. Okay, 11.
And since there exists a number 9 which is less than 11, like to the right of it, then you box it.
So you would box the 11?
Wait, did we already try this? Wait, this
I'm
is
not
like the same
sure.
definition as all isn't this the kind of the same thing as the number of
Kind
consecutive
of.
pairs that are decreasing?
But like it makes sense to me kind of because if you show that the boxes just keep on decreasing. I guess I think that's what you guys tried. I'm not sure though. I wasn't really paying attention when you guys were doing it. I was trying to do my own thing. Is my mic
So
down?
can boxes appear in this from this step?
Well, the
That
thing is,
looks like
like,
a face.
by your definition, at the end, everything is just a box.
Yeah, so we want to prove that everything becomes a box
Oh, okay.
eventually.
That means you just show that the number of boxes is increasing.
Yeah.
That depends. Because, like, you don't know, like, if you have, like, a number like 11 and 9, you're not sure if... Actually, no, never mind, I'm spamming. No, yeah, wait, yeah. If you have...
Yeah, this can become a box.
So, box and a number, if you swap it, always becomes a box and a box. That makes
So
sense,
it can
right?
become just a regular in a box.
Okay, that's what you already said. Okay. I don't know what I'm
So
doing.
that's why I have a box in a line, because it can be both.
And obviously you can't run an operation on a line in a box, because that's
Yeah,
bad.
and you can't also do it on a box in a box.
So wait, do you say, like, so if you have two regular numbers and you switch them? Hmm.
It can either become regular or box regular.
So you just have to show, like, the number of regular things is finite, something like that. Let me try. Wait. So if you had, like, the sequence, let's say 5. You know, let's just roll with this sequence. So 4 1. If you switched it, then if you switch it to, it'd be either 3. I don't know why I'm trying this. Okay, 3 4
Oops, I accidentally read the chat and I figured it out. Yikes! We've been going around a lot.
2 4.
I read the chat and I quote unquote figured it out.
Yikes! I read the chat and I read 2 sentences and I figured it out. This is so sad. But I still want to continue with our box argument though. I still kind of want to see how this ends up. If this box argument doesn't end up, I guess I'll just show the solution. That I literally just read the first 2 sentences of the math aces. Yikes.
I mean, we have been going on for a while, but yeah. So the thing
So,
is,
so
This
for
is
these,
2012. It's 2012.
can we get these boxes to keep appearing? That is the
yeah.
question.
So obviously for this operation works, we just show for the regular operation. So I don't know what I'm doing. Why am I running this on 3 4? That doesn't work. 4 1 becomes. The thing is, if you have a box to your left, and you're not a box,
Why?
I'm thinking. Yeah, if you have a box to your very left, and you're not a box, that means you're less than the box.
Yes.
I don't know
Or
why.
it could be equal.
Yeah, you could be equal as well. But if you're so
Wait.
is a box defined to be greater than or equal to, or just greater than? It should be greater than or equal to, right? Should be greater than or equal to, because then
Yeah, it should be
yeah,
greater than or equal to,
if
so
you
it
have a
should be
5, you have to
also be a
box that
box.
as well.
Okay.
Hmm. I mean, if it's equal to, yeah, then it's already boxed. If it's not boxed, then can you? Yeah, so we have to
Should I
show
just
that
share the
there's.
solution? This doesn't go anywhere. I can already tell this doesn't go anywhere.
Sure, I mean, I think
Yeah.
Because
okay,
it
wow.
boils down to can we prove that it basically proves that it boils down to can we prove that these operations that don't increase box can we prove that we can only do a finite amount of such moves, but
Yeah,
that's like what we were screwing around with
yeah.
earlier, and I don't think that works. I'll just share it.
All right.
It's not really my solution, I guess. I basically figured out how do I clear the whole board. I'll just erase it all.
Just erase everything.
Okay. Do. Erasing is fun and satisfying. Okay, there we go. So basically, what happens is that we know that earlier we did get to the result that that the number with the box cannot lose a box. So basically,
Yeah.
meaning the biggest number has to not be changed. Oh, oof. What am I doing? Yeah. So the biggest number must stay the same. It cannot increase, and we can see that.
Yeah.
Actually, yeah, it cannot increase. So we see that if we have, like, for example, n terms,
Yes.
and that maximal value is m,
Yes.
then that means the sum is bounded by mn, right?
Yes. I agree.
And then we see that xy becoming, my y's looks horribly like x's, becomes y plus 1 x, so the sum increases.
Yeah, increases
And then
by
we
1.
see that xy becoming x minus 1 comma x. We see that the sum is increasing because x was greater than y, or actually it's non-decreasing, so it could stay the same if
Yeah.
if
Be greater than or equal to.
x minus 1 was equal to y.
What? Oh, sorry, click on the wrong thing. Okay, there we go. That should hopefully clear up some lag. I turned off my preview. Okay. X minus 1 equals y. That has to be shown that's finite. 5, 4, 3, 2, 1.
Wait, what are we doing wrong?
What do you mean what were we doing wrong?
Why is the stream lagging?
I mean,
Is
I
that
had
on
my
Oxford
preview.
side?
I had my preview on, so it might have been. I don't know. I think it's probably the YouTube side because everything's like there's nothing that's like taking up a lot of the stuff because it's literally just a whiteboard. You're writing things on a whiteboard.
Okay, looks people are saying it's better now. That's good.
Oh, actually? Okay.
Okay, back to what we were saying. So we just need to prove that we cannot have infinitely many moves such that x minus 1 is equal to y.
Yes. Okay.
This is trivial.
That makes sense. Mm, if you have x minus 1y, you switch it over, it'll be equal. And then, let's see, like if you have like this, what's this become? 4, 4? No, it doesn't. I'm being stupid. Oh, never mind. Okay. So 5, 4, this switches. Oh, someone erased that. 5, 4.
Yeah, I'm rewriting it. No. This is a better sequence to look at.
Okay. Let me just erase this. So yeah, so 5, 3. Obviously, if you switch it, you can't. Actually, no. I don't know what I'm saying. It becomes 4, 5. But that you can't perform another operation on that pair.
You can't. No. Don't do operations on the ones that aren't x minus 1 is equal to y.
Okay, yeah.
Because we just want to prove that we can't do infinitely amount of these
Yeah,
operations.
I see what you mean. So that becomes 3, 3. This, I believe.
Yeah.
So
No, it should become 2. Wait, it should become 2, 3. Wait, no. It should become.
it should become 3, 3. Y plus 1x.
Hold up. Why is the sum increasing then?
Oh yeah, wait, what? Oh no, I performed the wrong operation.
I was about to say.
Yeah, I performed the wrong operation. So yeah, if you
2, 3.
take, yeah, I got confused right here. So yeah, xy becomes x minus 1x. So yeah, it should become 2, 3. So
Okay, and we see that this keeps sorting itself, right?
yeah,
Okay, this continues to keep sorting itself because it like because yeah, each of these operations always takes a strictly decreasing to strictly increasing. So you must eventually either have all completely sorted, or we must do a move where x minus 1 is not equal to y, right?
yeah.
Okay, yeah, and that finishes the problem. Very good.
Took a long time.
That took a while. We were being a little weird.
So should
Earlier.
we end the stream at this point? I think everyone's left. I don't see anyone
Not
else
everyone is left. We have 11 viewers.
Oh really?
Yeah. I mean, but
I'm still type this up.
if you
Sure.
want to end the stream, that's perfectly fine.
I'm fine with staying live. If other people want to stay longer. I'm gonna go down for about 10 minutes. You
I
guys can
still
keep on.
enjoy doing this. I still enjoy doing this, doing problems together, even if there aren't people watching.
Yeah, I mean, if you guys want to
Yeah.
keep on doing this, I can do this for a while, but I have to go for now. I'll be back in 10 minutes. You guys have control of the whiteboard, so
Chat,
you
do
don't
you
need
want
me here.
the stream to keep going? Y for yes, N for no.
So the great thing is that the Zeit board, you guys can control it, so I don't have to be here to do anything. So as long as my computer
Just
keeps on running.
keep it streaming.
Yeah. So I'll be back in 10 minutes.
Okay. So, so how do we wait? So, is our goal? Eli, are you there? Wait, so our goal is to just prove that.
We're
Akshay's
done.
going to be gone for the next 10 minutes or so. So this is a chat time.
We can just finish. I just want to finish the problem, man.
Oh yeah, we finished.
Problem.
Were you gone?
Yeah, okay. Unless we
Alright,
apply the move.
just in case
Next.
anyone is interested, okay? As of
Yeah.
right now, we have, let's see, 18.5 watch hours on the stream.
Nice.
Sweet.
It's pretty good. Alright, I'm going to pull an Akshar and disappear for 10 minutes. See you
Okay.
guys.
Goodbye, Noah.
Bye.
Yes. What? So there's can't be an infinite amount of that. Um, how do we prove that?
What? Prove what?
How do we prove that we can't do that an infinite amount of times?
Oh, so each time we apply to move, basically the two terms just switch positions. Either we eventually have a completely sorted list, or we have to at one point apply a move where x minus 1 is not equal to y.
What do you mean they just switch positions? Oh wait, no, I'm sorry. You're right. You're right. Okay. Yeah. No. Okay. That's cool. Yeah. No. That's cool. Okay. Okay.
That's pretty cute. Okay, I'm gonna take a
Oh.
screenshot and save this.
Ah, good God, that took too long. What topic should we do, guys? Is there a way to do polls in the chat?
There's not enough people to
Really? All right, let me try switching to the CNCM count, see if that works.
Okay, let's clear all. I want
Right.
either NT or Geo. I want to do a Geo. I kind of want to do a Geo, to be honest.
Hey, I mean the two people are Akshar and Noah are gone, so it's a perfect opportunity to do Geo.
Should I stream? Wait, hold up. We can't do it on here. Actually, let's just do NT. Let's do NT because
Oh, yeah,
my
yeah,
view of
let's do it.
Geo is like one person streaming a GeoGebra, and then they're just doing it, and while other people are talking, kind of. Let's just do an NT. Yeah, let's just do an NT.
Oh, like
Is it? Do you have it up or?
yeah, I have it.
Okay.
How do I save it? I don't know how you copy paste an image. I'm sorry, how you copy an image. Insert.
I just did it.
Okay, that works. 4 integers.
Okay.
Okay, yeah. This is 1996 and 1.
Yep. Okay. So we have the difference between this number and the next number on the circle. What does that mean? So we have A, B, C, and D. Okay, and then each number on each step we simultaneously replace each number by the difference. Okay. Okay. Okay, I see. Okay, I see. Okay, I understood the problem. The circle is not actually that important. We just have A, B, C, and D becoming A minus B, becoming B minus C, becoming C minus D, becoming D minus A. And that took so much space, I'm going to rewrite that. A becomes A minus B.
The difference of the difference of the difference of the difference.
So is it possible after 1996 such to have numbers A, B, C, D such the numbers, okay, are primes? Ah.
Hi. I'm not back yet, but I'm coming on here on behalf of the chat because everyone right now is saying that the stream is incredibly pixelated and laggy. So stop for a second.
Okay. I'm still trying to understand the problem.
But you guys are doing new problem?
Yes. We're looking at yeah. I'm
It
still
says
trying to get a grasp on this problem
incredibly
right now.
blurry.
N1? Guys, fix the stream we can't see. What? Is that true?
I don't know.
It's fine right now.
Is it still bad?
There's nothing we can do
Okay,
on my.
it says
I
it's
can't do anything
fine
on my
now.
end to increase the quality.
It's still there. Try refreshing.
I mean, I think it's just because YouTube. I mean, I don't know. I think it's something on YouTube's end. Cause like there's quality.
Yeah, I
It says
mean,
360p.
YouTube is not
Yeah, okay, so
necessarily.
go into your gears button. There's like a settings button, like in the gears button on the bottom right. Go to quality and pick 720p 60. It says auto 360p for me, and when I changed it, it fixed me for that.
On my end, it's auto 480p. So.
Now, if you go to quality, you can change it up to max. CNCM, can you
Alright, we
shout me
are
out?
encroaching
Sure.
on
Shout out
20
to Andy.
watch hours.
I don't know how to pronounce your name, unfortunately.
Yes, shout out to Andy Zoo. Wow, okay, so the refreshes. Yeah, it just showed that a bunch of people refreshed because we got a lot more views and a lot less average watch time, which is cool.
Is this an N1?
Yeah.
No, ow, I accidentally smashed my hand.
Full cycle. We've gone N, A, G, C, and we're back to N. I don't like this number theory, bro, to be honest. 4 integers are marked in a circle. Each step we simultaneously replace each number by difference between this number and this number.
I'm still not back. I'm gonna go.
Interesting thing to note is that the sum of the numbers are 0 always after the first move.
Oh yeah.
Yeah, it makes sense because A minus B, B minus C, C minus D, G minus A.
Does it matter that's 1996 or does it?
It's just an arbitrary constant.
Is it
It's
possible
arbitrarily large constant.
Does this work on the? Is
Wait,
it possible
what is
even on
after
the
1990? What does that mean after 1996? Does it mean like 1996 moves?
Steps.
Steps? Yeah, okay.
Is this even possible? Is this even possible on one step? Oh, I'm sorry, in 0 steps.
What do you mean 0 steps? You can just let all. Oh, is it okay? Is it possible at 0 steps? Let's try to construct something then.
I would have to assume it is possible, but otherwise this would be trivial. But
yeah.
BC minus AD. I don't like because the negative does play a role, unfortunately. So you have to you can construct with negatives as well.
Oh,
Yeah.
Zero isn't prime, I think. That's a good point. The absolute value.
Have you guys constructed something? I can't.
I'm trying to.
Let me try to as well. I mean, I'm just doing it on my own sheet of paper up.
Wait, hold up. Can't you just let it be 1, 1, 1, and negative 1, and they all become 2 and 2 and 2?
Okay, yeah.
It is possible. Okay, is it possible when the sum is 0?
What about if the sum is 0?
What happens when we have 1, 1, 1, negative 3? You get ugly.
-3.
Well, so sum is always 0,
-1.
right? On each cycle
1.
after the first move.
Yeah,
Okay. So.
it's probably critical information. So if you have A plus B plus
Me
C.
here only knowing nothing.
Well, I mean, something that's useful is that A, B, C, D all have to be relatively primes in
Can
order
you
for
make
it to
something with AB
have a
minus
chance.
CD, AC minus BD, AB minus CD? Bruh, A plus B plus C plus D equals 0. Bam, boom, bop. Okay.
Bam,
I think that's
boom,
a
bop.
comment on the 1, 1, 1, negative 1.
So the sum, it's possible to show. This is a really, is this really number theory?
It looks
I
like
don't know.
it does look number theory.
I'm not. Oh, okay. I mean, we have to try to show if it's constructible. All right.
This is so pathetic. I have no idea.
This is a really interesting problem. That's all I can say.
Indeed.
Like, wow.
This is kind of awkward. How do you construct this?
I mean, if we can't get a configuration, eventually we're supposed to try to prove that this
Is what confuses me is the 1996 part because we can't even construct something for ABC is equal to 0. CD is equal to when A plus B plus C plus D is equal to 0. So I have a feeling that 1996 is just a red herring, and we just need, and the condition is just that A plus B plus C plus D is equal to 0, and we have to prove that they can't all be prime or something.
Hmm.
I find it possible that the answer is just no.
Just write no, get 7 points. That's how you do it.
No. Edie.
Yo, epic proof moment.
Oh yeah. Well, it was the Geo edition, but
Let's try to
Geom.
try to fix something. What happens if you fix something as 0? Does that not work at all? Trying to see. Because then the condition becomes, what is it? BC BD CD. There's something in common between those two. Actually, wait.
Can we get rid of the absolute values? Yes, we can. Let me do it real quick. Oh wait, I did not mean to do that. Okay, hold up. Let me remove this mess. Yes, we can. So basically, we have that either. So if we ignore the absolute values, we can have that either 0 positive, 0 negative, 2 are positive, 1 is negative, 1 is positive, 2 is negative, or 0 is positive, 3 is negative. We want to, if it's this, we can just clear the absolute values and be free. If it's this, we can just multiply everything by -1, and we should be clear. And then for this one, I'm pretty sure if you switch like B and C, for example, I'm pretty sure you can just clear the absolute value. I mean, yeah, if you switch B and C, or like for example, let's say if this one is the positive one, and if we switch B and C or A and D, I think that yeah. And then if we have this, then we can turn this into 0, -3, and then take the -1 and multiply everything by -1 to take this to here. Does that make sense? I'm going to take that as a no.
I just don't think it's possible. I think I guess you're supposed to prove that you can't make those 3 prime.
Yeah, I don't think this is possible. So
Unless there's like some insane configuration. I mean, you never know.
there's normally not these insane configurations.
True.
Um,
Okay. Where to begin?
I think we can, like from what I said, I think wait, no, that involves no, it doesn't. Hold up, let me think about this. Yeah, I think we can just drop the absolute values. We should be good. You want me to explain that? Why we can drop the absolute values?
Yeah, can I do it again, please?
Okay, so basically we can consider that these 3 terms without the absolute values, right?
Yeah.
There's 4 cases where 3 of them are positive, 0 negative, and all the way down, right?
Yeah.
So for this case, we're already done. We can just drop the absolute values, right?
Can you? I mean, oh yeah,
I
you
mean,
can.
all
Yeah, you
3 terms
can.
are positive, yeah. And then for this one, you can just multiply everything by -1 and you get all positives, right?
Yes.
So let's say for this one, we'll log that shoot. Okay. So let's assume that the one that I circled in red is the positive one, okay?
Yep.
So then in this case where we only have one positive. And that means that we can switch B and C. We switch the positions of B and C, and we get that the other 2 become positive, and the one that was already positive stays positive, right?
Can you say that again?
if we switch B and C, so for example, if B is equal to 2 and C is equal to -3,
Yeah.
then B becomes -3 and C becomes 2.
Yeah, I see what you mean.
And then that means that all three terms becomes positive, right?
Oh yeah.
And then for the last one, we can basically make the same argument to make this all negative, right?
Yeah.
And then if we have all negative, then we can just turn them to all positive by negative by multiplying everything by -1, right?
Yes.
So that means that I'm pretty sure we can just drop the absolute value conditions and assume that they're all positive, right?
Okay.
Okay. Actually, are we allowed to? Oh my gosh, are we allowed to log that? I'm actually not sure. Is switching B and C, like for example, is that something that we're allowed to do though?
I mean, I'm not sure. Like,
Switching B and C seems wrong.
If you wait, what did you hear say? What do you say? Sorry.
Switching B and C?
Yeah,
That seems wrong somehow.
it does feel wrong, but I can't tell how.
let's see.
And maybe
Fix.
what I'm talking about is not even actually that important. Let me just try some random crap.
I mean, what is Discord?
I'm back.
Hello.
Oh no.
Hello.
No, I think you'd be good for this problem.
I just killed the problem, right?
What do you do?
Yeah, I just killed the problem on accident. Holy crap! What in the world?
What in the world did you just do?
What?
Wait a minute. Oh my god.
I'm actually what in the world? Hold up. Wait, I don't think this
Wait.
finishes though. We have to prove that none of them are 1.
Wow. That's impressive.
What the heck?
Is it BD? BD CD squared?
It's so cute. It's so cute.
Before
So this is equal to P, right?
You're actually
have,
kidding me. Is this actually the problem? You're
Wow.
actually
That's
22
impressive.
by the way.
This actually kind of makes me sad.
So two cases, either B plus B, so either B is equal to
Wait,
where's our case bashing?
wait, just what are the other cases? A, C should be just it
There
should
are
be
4 cases that I can think of. I
wait,
don't
there's
like them. Either B plus D is equal to 1, B plus D is equal to -1, or C plus D is equal to 1, or C plus D is equal to -1.
I think the
Those are
signs
the-
are not that important here. Wait, can we always just keep on substituting A? I think that is promising because if we eliminate A, that's a lot nicer.
Okay.
So we get that the second term becomes B plus C times D plus C, and this third term becomes blah.
oh
I'm
you
assuming B
removed
plus
A?
D times B plus D.
Oh, I remember. Not beautiful.
So we just prove that these all can't simultaneously all be prime. Or
Yeah,
all
and
these
that
can't
works
be-
because, for example, if we say we'll log that this is 1, right?
Mhm.
And that means that this is also 1. And that means that neither of these two are 1, right?
Yeah.
Not necessarily.
Well,
It could-
actually,
oh
no.
wait, yeah.
Hold up. Can it? Wait, does that make
No,
sense?
no, wait, yeah, because B plus C and B plus B would have to be not 1. Because if they were 1, then it would be 1, which is not. Then the product would be 1, which is not prime. Which means the top one is also. Which means the top one is a product of 2.
Yeah.
Product of 2 prime numbers. And then we're done.
Yeah, we're done. Okay, that was pretty sad. That was actually so sad. Yikes.
Wow.
Okay.
Amazing problem.
Do you want to end the stream here? We
Why
just
does this problem exist? It's just not.
We just got past the 2-hour mark. Do you want to end the stream here?
Let's end
kinda-
it.
You want to end it?
Sure.
I think so. It's getting late.
Okay.
And besides, our viewer count has, like,
Let's just make a write up real
fallen.
quick.
Are
Very,
wait,
very
let's
fast
ask one
in the
last
last
question. Are our
10
viewers
minutes.
okay with ending the stream?
I think we can do like it would take us a while to do another problem. I don't think it'll be achievable.
Yeah, and it's 10:25. Some of us have school tomorrow. Some of us
Turbo
don't.
the snail.
Turbo the Snail? That's like one of that really, really, really annoying movie.
Yeah, noticing how people aren't saying no, then I think we're good to end the stream. Let me type this one up though. It'll be pretty quick.
So, 3 problems today. This
Hey,
problem,
it's a proven. I
Oh,
made
did
a
you type it
very,
up?
very sketchy sketch.
If I am correct with how this calculation works, when this stream ends, we should have 22.2 watch time hours, which is kind of cool.
Watch us more.
Hey, Harry, can you is there a way to actually?
That's
Turn-
like a full day in 2 hours.
Well, that's considering if only one person watched, but
And sometimes we only get 2 hours in a full day.
huh?
I'm saying like on most days where we don't stream, right?
Yeah.
We get like 2 hours, 2 watch time hours, right?
That's actually
But
kind of
like
that's
right
actually kind of
now,
cool though. Like 2 hours per day. It's pretty cool.
I mean, yeah, that's pretty cool, but we got 22 just now on this one stream.
Thank you for watching the stream, Drop.
Trump? Trump is
What?
on our stream?
No, I said Chirag.
Oh, I'm sorry. I heard Trump.
We're not equating Chirag with Trump.
No. Regardless of your political beliefs, you're not Trump, you are two individual people.
Yeah, physically, you cannot be Trump.
Oh,
Oh,
sorry.
I guess Trump. Well, no, you can't be Donald J. Trump. I don't know. I don't know anymore. We're done.
I think it's Jay. Yeah.
You can change your name to Trump. I don't if you want. I don't know.
How much would that cost?
At what cost? I don't know. How much money does it take to change your name?
I know, but like, it might cost more because it's Trump.
I don't think it matter. I don't think that they care. You can't own a name, right?
you can't
Um,
copyright a name.
Governments can prevent people from getting certain names.
okay, let's just stop talking about this.
You're not even getting.
Serves no
You're not preventing
purpose.
from getting the name Trump.
Yeah,
Trump is just
let's
a
end the
regular
stream
name.
here, okay?
All I have to do is press a button.
Alright, well,
Okay,
Thank
you
you,
everyone
everyone.
for watching.
Let me just press the
Enjoyable
button.
stream.
please make sure if you are here, right? Did you already press the button?
No, I did not.
Alright, please make sure if you are here to like and subscribe if you have not already. We hope to see you soon for another lecture, stream, etc.
Harry Chen.
Yes,
Next.
Lecture by Harry Chen.
What? Oh,
it does not. It takes a decent amount of effort to solve these problems, and it takes virtually no effort to click a red button on your screen to subscribe to this channel. The next subscriber will be
give
the
us
350th.
We desperately need him. We need
Just
your
pause.
support.
We need
Get
your
money.
support. We're
Let's stop
desperate.
sounding.
We're getting
Let's stop.
40
Let's
frames
stop
per
sounding like
second.
beggars and end the stream.
We're not beggars, bro. Like, okay, it's not that hard. If you're
Yeah,
if
I'm
you're
just
not
joking.
subscribed,
However
click
YouTuber
subscribe.
works, though.
Huh?
This is like how every YouTuber works, though.
Yeah, it's
No.
true.
Well, yeah,
Like,
that's true.
that's a
But we're
common
not
thing.
like
You ask
pro
for likes and
YouTubers.
subscribes. As cliche as it sounds, it helps.
More intensity.
Yeah.
Okay. Oxford, can you end the stream?
All right. Thank
Yeah.
you.
End it before. End this
Bye.
before Noah sounds